Hello everyone. So in this video I'll show the circuit, the design that interacts with the PIR sensor, which is a passive infrared sensor, triggering an alarm via a buzzer, a piezo buzzer. This is the PIR sensor. It actually triggers a signal once any movement is shown once any movement is shown in its perimeter, and then the Arduino identify this movement and triggers a sinusoidal signal into the buzzer, and the NMOS the NMOS transistor here opening the path, the bias for the relay, enables the relay control to short circuit the negative terminal of the buzzer to the analog ground. And then let's take a look at the simulation. So here the signal level at the output of the PIR sensor is low, 0 volts, and there's a mid voltage level at the output, the negative terminal of the piezo buzzer. So once we apply the movement in the PIR sensor perimeter, this indicates that there is a burglar or a thief or someone in the intruder in the vicinity of the PIR sensor, and then we'll hear the alarm triggered. So once we're out of the vicinity, there is no alarm. Only once the circle, which acts as an intruder coming into the perimeter of the sensor, then the alarm is triggered. So once there was a identification of the intruder, the signal here went to 5 volts, which is a logic high, and the voltage at the output of the piezo buzzer, the negative terminal, went to 0 volts, went to low, since the relay short-circuited to the analog ground. The functionality of these devices, the diodes and the resistor, is to make sure that once the coil at the relay, once the NMOS transistor is disabled, so the current that flowed through the coil, through the inductor here at the relay, if there was no path to conduct the current, there was an immediate under voltage or over voltage, overshooting or undershooting at the supply of the circuit. So to avoid it, the diodes are connected in parallel connection and are placed in the ends of the relay coil in the opposite polar direction. Having this current pass through the diodes will avoid any adverse effect on the power supply. That is all for today. Thank you very much.